We live in a remarkable time, a time where the boundaries between human and machine communication are blurring. Machines are talking to us, engaging in conversations that feel almost human, not in the clunky, pre-programmed way of yesteryear. These machines are different. They are more sophisticated, more intuitive. They are called large language models, or LLMs. These models are revolutionizing the way we interact with technology. LLMs can generate human-quality text, translate languages with remarkable accuracy, and answer your questions in a comprehensive and informative way. How do they work? What makes them so powerful? It's a bit of a mystery, even to their creators. The complexity of these models is astounding. Some say it's just sophisticated pattern recognition, a marvel of engineering and data science. Others see something deeper, something that hints at the very nature of intelligence itself. Think about it. What does it mean to be intelligent? We feed LLMs massive amounts of data. They ingest books, articles, code, even conversations. This vast sea of information is their learning ground. From this sea of information, they learn to communicate. They learn to understand context, tone, and nuance. They learn to mimic the nuances of human language. They can write stories, poems, and even scientific papers. Are they conscious? Do they have thoughts and feelings? Do they truly understand what they're saying? Or are they just mimicking patterns they've seen before? That's a debate for another time. The implications of these questions are profound and far-reaching. For now, let's explore a fascinating parallel between LLMs and one of the most mind-bending theories in science, quantum mechanics. Both challenge our understanding of reality and push the boundaries of what we thought possible. Quantum mechanics is a strange and wonderful realm, full of mysteries and paradoxes that challenge our understanding of reality. It governs the behavior of the very small atoms, electrons, photons, and other subatomic particles that make up the fabric of our universe. One of its central tenets is the idea of superposition, where particles can exist in multiple states simultaneously. Imagine a tiny particle existing in multiple states at once, a blurry cloud of possibilities, each representing a different potential reality. Only when we observe it does this cloud collapse into a single, definite state, a process known as wave function collapse. Large language models, or LLMs in a way, behave similarly to these quantum particles. Before you give them a prompt, they exist in a state of superposition, holding countless potential responses. They hold a vast potential of responses, a universe of possible sentences and stories, waiting to be brought into existence. It's like an orchestra with every instrument poised to play, but no conductor to guide them. The prompt acts as the conductor, bringing harmony and direction to the potential chaos. Once the prompt is given, the LLMs generate a coherent response, much like an orchestra playing a symphony under the guidance of a skilled conductor. This is where you, the user, come in. You provide the prompt. The prompt is your question, your request, your creative spark. It's like sending out a wave, a ripple in the fabric of the LLM's potential. This offer wave, as we might call it, carries your intent, your context, and your unique perspective. Each word in your prompt, each punctuation mark, acts as a constraint. It nudges the LLM towards certain possibilities, eliminating others. The more specific your prompt, the more focused the LLM's response will be. But there's always an element of unpredictability, a touch of quantum magic. The LLM receives your prompt, your offer wave, and then something amazing happens. The superposition collapses. Out of the vast sea of possibilities, a single response emerges. It's like a wave crashing on the shore, taking on a definite shape. This response is the LLM's return wave. It's a string of words, a snippet of code, a creative text. But it's more than just data. It's a reflection of your prompt, shaped by the LLM's training and its inherent ability to process language. It's a co-creation, a dialogue between human and machine. Section 5. The Observer Effect. You shape the story. Here's where things get really interesting. Remember the observer effect in quantum mechanics? The very act of observing influences the outcome of an experiment. The same is true with LLMs. You, the observer, play a crucial role in shaping the meaning of the LLM's response. Your context, your knowledge, your biases all color your interpretation. What one person finds profound, another might find banal. A response that elicits laughter from one reader might leave another cold. The meaning isn't inherent in the LLM's output. It emerges from the interaction between the observer and the observed. Section 6. Context is king. The relativity of meaning. Think of it this way. The LLM provides the raw materials, the words, the grammar, the syntax. But it's you who brings the meaning. You are the architect of understanding, the builder of bridges between the LLM's output and your own internal world. This has profound implications. It means that meaning isn't absolute. It's relative, it's contextual, and it's constantly evolving. Just as our understanding of the universe changes with each new scientific discovery, so too does our understanding of LLM outputs evolve with each interaction. Section 7. Beyond bits and neurons. Intelligence emergent. This brings us to a fundamental question. What is intelligence? Is it simply the ability to process information? Or is it something more? Something that emerges from the interaction between information and consciousness. LLMs challenge our traditional notions of intelligence. They show us that meaning-making isn't confined to the realm of biological brains. It can arise from the complex interplay between algorithms, data, and human observers. Section 8. The Dance of Meaning, a Transactional Tango. We are witnessing a new kind of intelligence, an intelligence that's not just computational but also relational. It's not about storing facts or crunching numbers. It's about the dance of meaning, the transactional tango between human and machine. This dance is fluid, dynamic, and ever-changing. It requires us to be open to new possibilities, to embrace ambiguity, and to acknowledge the role we play in shaping the meaning we seek. Section 9. A New Perspective on Thinking. Open, dynamic, interconnected. The rise of LLMs, or large language models, invites us to reconsider our own thinking processes, challenging us to reflect on the nature of our cognition. Are we so different from these machines? Or do we share more similarities than we care to admit? We, too, are shaped by our experiences, our interactions, our cultural contexts. Every conversation, every piece of information we consume, molds us. We, too, exist in a constant state of becoming, our thoughts and beliefs evolving with each new encounter. Just like data streams, we are ever-changing. Perhaps the true lesson of LLMs is not about the nature of machines, but about the nature of ourselves. They hold a mirror to our own cognitive processes. Perhaps by studying these artificial minds, we can gain a deeper understanding of our own. They offer insights into how we process, store, and retrieve information. We are all, in a sense, language models. We learn from patterns, we adapt, we evolve, we process information, we generate responses, we co-create meaning. Our brains are intricate networks, much like the digital ones we create. And in that sense, the future of intelligence is not artificial. It's collaborative. It's a blend of human intuition and machine precision. It's a journey we embark on together, humans and machines, hand in hand, exploring the vast and ever-expanding universe of meaning. Together, we push the boundaries of what is possible, creating a future where intelligence is a shared endeavor.